We have introduced how to graph the parent sine function y equals sine x when x was in degrees or radians using the table of values, and then we explained how to graph other sine functions that showed either a reflection across x-axis or vertical dilation, either a stretch or a compression. In today's lesson, we will introduce how to graph other sine functions that show, in addition to reflection across x-axis and vertical dilation, they show a vertical translation, upward or down. We will take a new example, y equals sine x plus 2, where x is in radians. As you can see here, we have plus 2, a k, and we know that plus k or minus k, they represent vertical translation, either upward or downward. Here we have a plus 2, that means we have a vertical translation 2 units upward. And as we know that vertical translation, they change the values of the y and the parent function. When we need to start the graphing, we need to start from the table of values of the parent function and do necessary changes. Y equals sine x, it's in radians, so the x values, they range from 0 to 2 pi, so 0, pi over 2, pi, 3 pi over 2, and finally 2 pi. The y values are 0, 1, 0, -1, and 0. Now, since we have a vertical translation by 2 units upward, we need to change, as we said, the y values. This means we need to add 2 to the y values. So the y must be plus 2, all of them are plus 2. As you can see, the x values in y equals sine x plus 2, they don't change. They're the same. Only the y values are gonna change. The y values are going to be 2, 3, 2, 1, and 2. We will be using this table to graph our sine function, our given sine function. When we start the graphing, as we mentioned earlier, we need to have a scale. I chose here each 3 squares 1 unit, so I have 0, then 3 squares pi over 2, then pi, 3 pi over 2, and finally 2 pi. Now, as you notice that here all our y values are positive, so we're going to use the positive part of our y values. I'm going to move 2 units as 1 to have a clearer graph. 0 is 2. We have then pi over 2 is 3. Pi for 2. 3 pi over 2 is 1, and that's our minimum. 2 pi is 2. Now we need to connect the points in order to have our graph. As you can see in the graph, the maximum is 3 and the minimum is at y equals 1. From the function that you have, the amplitude, which is the absolute value of a, is 1. We're going to verify it by calculating it from the graph. The amplitude from the graph is equal to, as you all know that the amplitude is equal to the value of the maximum, which is 3, minus the y value of the minimum, which is 1, divided by 2, and that's a 2 over 2, and that's a 1. So the formula also verifies our amplitude from the function. As you can see, also the period is 2 pi because the x values range from 0 to 2 pi. The one cycle has a period of 2 pi. Another example, y equals sine x minus 1. X here is in degrees. As you can see as well that we have a vertical translation 1 unit downward. We will start from the table of values of the parent function y equals sine x. As you can see here, we have a vertical translation downward by 1 unit, so only the y values are going to change by subtracting 1. So minus 1 from each y value and the parent function. 0 minus 1 is minus 1. 1 minus 1 is 0. 0 minus 1, again minus 1, minus 1 minus 1, that's a negative 2, 0 minus 1 is a negative 1. We will be using this table in order to graph our given sine function. As you notice, the y values are negative, so we will be using the negative part of the y-axis. We will choose a proper scale in order to graph it. I moved each 3 squares 90 degrees, and on the y-axis, each 2 squares 1 unit. We will start the graphing. As you notice, the 0 has a y value of negative 1, 90, 0, 180, negative 1, 270, negative 2, and that's our minimum, 360, negative 1. We connect our points to get our sine function, our given sine function, and then as you can see here that the minimum value is, the y value of the minimum is negative 2, and the y value of the maximum is 0. If you want to verify the amplitude given in the function a is equal to 1, so the amplitude is absolute value of a, which is 1. And then if you want to verify it from the graph, as you can see here, the amplitude is equal to the y value of the maximum, which is 0, minus the y value of the minimum, which is negative 2, all divided by 2, and that's a value of 2 over 2, 1. So also the formula justifies and verifies that the amplitude is equal to 1. Another sine function, y equals 2 sine x plus 3. As you can see here, we have a vertical dilation, a stretch by a factor of 2, and we have a vertical translation upward by 3 units. So both of those are going to affect our y value of the parent function. As you can see that the table of values for the sine x is written, we are going to change the y values in order to obtain the y values of the new sine function, 2 sine x plus 3. What are we going to do? We are going to multiply the y value of the parent function by 2 and add to it 3. So it's going to be 2 multiplied by 0 plus 3, and here 2 multiplied by 1 plus 3, 2 multiplied by 0 again plus 3, 2 multiplied by negative 1 plus 3, and 2 multiplied by 0 plus 3. For the first one, 2 times 0 plus 3 is a 3, 2 times 1 plus 3, that's a 5, 2 times 0 plus 3 is a 3, 2 multiplied by negative 1 is a negative 2 plus 3 is a positive 1, and finally 2 multiplied by 0 is 0, added to it 3 is 3. We're going to use the obtained table of values in order to graph our given sine function. As you can see, I chose the proper scale in order to graph the given sine function. I moved by 3 squares on the x-axis and by 2 squares on the y-axis. All of our y values, as you can notice, are positive, so we're going to use the positive part of our y-axis. Starting to plot the points, as you can notice here that the 0 has a y value of 3, the 90 a y value of 5, and that's our maximum, 180 a value of 3, 270 has a y value of 1, and that's our minimum, 360 has a y value of 3. Now we need to connect the points to obtain the graph. As you can see here that the graph has a period of 360 degrees and has an amplitude of 2. Let's verify it using the formula. The amplitude is equal to 5 minus 1 divided by 2, and that's a 4 over 2, which is 2. So the formula of the amplitude also verifies the amplitude that is found by the absolute value of a, which is absolute value of 2 equals 2. In a new example, y equals minus 0.5 sine x minus 2. Here the transformations that are found are a reflection across x-axis due to the presence of a negative sign, 0.5 a vertical compression by a factor of 0.5, and a vertical translation 2 units downward due to the presence of a negative sign. We will graph it using the table of values of the parent function and then doing the necessary changes. From the table of values of the parent function, we are going to multiply the y value by negative 0.5 and then subtract a 2. So we will have negative 0.5 multiplied by 0 subtracted by 2, and the value will be negative 2. Also here we have negative 0.5 multiplied by 1 and then minus 2. So minus 0.5 minus 2 will be negative 2.5. Again, negative 0.5 multiplied by 0 minus 2, the answer will be negative 2. Minus 0.5 here multiplied by negative 1 and minus 2. We will have a positive 0.5 minus 2, and that's a negative 1.5. Finally, again, minus 0.5 multiplied by 0 minus 2, the answer is minus 2. As you know, the x values are kept unchanged, so they will be 0, pi over 2, pi, 3 pi over 2, and finally a 2 pi. We will be using this table of values in order to graph our given function. As you can see, I took 3 squares on the x-axis for pi over 2, and then pi, 3 pi over 2, and 2 pi. On the y-axis, I took each square as 0.5. And as you can notice that the y values, as you can see, the y values here are negative, so we will focus on the negative part of the y-axis. Let's start plotting the points. When the x is 0, the y is negative 2. When x is pi over 2, it's negative 2.5. Then when x is pi, it's negative 2. 3 pi over 2, negative 1.5. 2 pi is negative 2.5. Then we connect the points to get our graph. As shown from the graph, we have a period of 2 pi. The amplitude from the function that is given is the absolute value of a, absolute value of 0.5, and that's 0.5. Let's verify it graphically. We know that the amplitude is equal to the y value of the maximum. The y value of the maximum is negative 1.5 minus the minimum, which is negative 2.5, all divided by a 2. So the amplitude is equal to minus 1.5 plus 2.5, all divided by 2, and that's a 1 over 2, which is equal to 0.5.